The first part of our note here today on rational exponents just involves you actually doing some calculations and seeing what patterns you might notice. So I'll start you off here. The first column of part A, you're just evaluating the base with an exponent of 2. So 1 squared is just a 1, 2 squared is 4, 3 squared is 9, and so on. And then you're evaluating the square roots. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. This is where it might get tricky. What we want to do is input an exponent of 1/2. So depending on your calculator, for example, my calculator, I would go 1, and then I've got an x with a y up in the air as my exponent button, but you would put in whatever you've got. But then I'm going to use my bracket button and do 1 divided by 2, close the bracket, and that will get me what 1 to the exponent 1/2 is, which does equal 1. And then I would do the same with 4 to the exponent of 1/2, which is equal to a 2. So hopefully that will get you through that first part for part A. For part B, 1 cubed you should be able to figure out as 1, 2 cubed, again, you're just using your exponent button. 2 cubed would be an 8, 3 cubed is 27, and I only know those real quick because I've been doing this forever. You might have a special cube root button on your calculator, and for me, I do have a cube root button. So the cube root of 1 is 1, cube root of 8 will end up being 2, and so on. If you don't actually have a button with a cube, mine happens to be under second function, like I have to use my shift key for that. You might not have that one. You might have one instead that has an X, kind of like that. And again, that might be a second function button. In fact, mine doesn't even have that. I have the cube root and I have the square root. I'm just looking very carefully at mine. The up above my exponent button is that X to the Y. Up above that button, I see a X and then a 1 over Y, I believe it says there. That is what I can use actually, which you're going to find a pattern here, okay, between these things. So if you don't have a button that you can use when you get down here for the fourth root, just do this column, and then we'll make a conjecture from there. Okay, go ahead and do that. Okay, so we're going to look at our conjectures here and see what we can come up with for patterns. Now, when I square a number, we should already have established in the past that the square root and the square of a number would be inverse operations of each other. They undo one another. So if I have 6 squared, I get 36. If I undo the square on that, I'm square rooting that. Square root of 36 would be 6. What I want you to notice is that this middle column and this last column, the answers are the same. So that's telling me then that it looks like the square root of 1 is the same thing as 1 to the exponent 1/2, or the square root of 4 looks like it's the same thing as 4 to the 1/2. So I'm conjecturing here, I'm coming to the conclusion that maybe the square root is the same thing as an exponent 1/2. So if we move down to the cubes here, I've got all my cubic numbers, the first 6 cubic numbers here, and the cube root, of course, would be the opposite of an exponent of 3. So you can see that these are really just the backwards of each other here happening. The 27 and the 3 and the 27. And again, these look like they're equivalent to each other. So it looks like if I have the cube root of a number, that's the same thing as that number to the exponent 1/3. Okay, so then let's move down into the last one. I just had a mixture of different numbers here, but 1 to the 4th, I got the 4th root, and these two columns again ended up having the same answers. So again, it looks like whatever number is here with the root will be the denominator of the exponent that is a fraction. So a fraction is a rational number, and that's why the title of this is Rational Exponents. Okay, so our pattern, we've talked about the patterns, the conjecture we make is if we're finding the nth root of a number, So I'll just use a as my number, and n is not out in front. It's not, I'm not writing this. This is something else. That's not, we want that n to be up kind of in the air, kind of like an exponent, but in the crook of the root symbol. That's the same thing as that base, that radicand here, to the exponent 1 over n. Okay, so that is what we need to know as our rational exponent rule. So let's put this into play with some examples here. All right, so from the previous page, if we had an exponent of 1 over n, that's the same thing as taking the nth root of that base. So we call this the nth root. So that's a quotation mark there, the nth root. And then that's supposed to be a closed quotation mark there. Oh goodness, that's not so great. All right, so that's the nth root of a. Now similarly here, this n on the bottom of that fraction is going to go in the root symbol, but what do we do with the m? So let's talk about this for a minute. I'm going to use the power of a power rule backwards here. I'm going to break that m over n to be the same thing as m times 1 over n. So think of these as multiplying fractions together, multiply your numerators together, multiply your denominators together. So I'm just breaking those up into two separate pieces. So then this part here becomes the nth root of a to the m. Now I could have broken that up a different way. I could have broken that up to be a to the 1 over n times m. Now let me just get rid of this so it's not in the way. So hopefully that will still be on the video and I didn't totally get rid of it. So that 1 over n could go inside the bracket and then the m on the outside, which then would mean I could take the nth root of a all to the exponent of m. So this can really be written two different ways, this or this. It's both are correct. All right, so let's practice using the correct button on our calculator. So you need to take the fourth root of 625. So again, depending on how your calculator works, I need to know on my calculator that this is 625 to the exponent of 1/4. You might have that special root button. Again, it could be an x and then y. It might be a second function button, but for me, I actually have to use the second function exponent button to get this. This should give us an answer of 5, I believe, here. Okay, so try and work through these questions. The second example here is writing it in radical form, so it's the backwards of the one before. So a 1/4 would be the same thing as the fourth root of 81. All right, so try those and then take your work up with the video. All right, so for part B of this example, the fifth root of 16,807, I got 7 as my answer. Part C, I evaluated what was inside the bracket first. I got a 3, the fourth root of 81 was 3, and then 3 cubed is 27. The cube root of negative 216 is negative 6. And then when I tried doing the fourth root of negative 4096, it's not possible. You should get an error on your calculator if you're using a negative base with that. If you didn't get an error, you either left out the negative or you didn't put the negative in brackets with that. But you should be getting an error, and that's because you can never take an even root, like square root or fourth root or sixth root, of a negative number. You can take the odd root of a negative number, but you can't take the even root of a negative number. So just keep that in mind, that you should get an error there, and you can't take the even root of a negative, but you can take the odd root of a negative. All right, the next group here, we'll figure out some answers. All right, and from here I got 5 and then negative 3. For part D, you'll notice the exponent is negative, so the base isn't happy where it is, so I slid it down to the bottom. And then I took the sixth root of 4,096 and got 4, but that gives me 1/4 then as my final answer. The point two is really 2/10, and in lowest terms, that's 1/5. 243 to the 1/5 is just a 3. So you might be able to just enter in 0.2 as your exponent and get that answer as well. All right, write in power or exponent form, then evaluate. So we're going to change these to exponents and then get answers to them. So try those out. The first one here, that's the same thing as 64 to the 1/3. So that's my power form. And then the cube root of 64, I believe, is 4. So try the rest and then I'll put the answers up. Okay, so you'll see that part B and part C, they look different initially, but really they both have an exponent of 2/5 when you write that in the exponential or the power form. All right, the next example, I'm telling you that 3 to the 5 is equal to 243. So that means when I have this 243 here, I can rewrite the fifth root as an exponent of 1/5. And then 3 to the 5 is the 243. So I'm just going to replace the 243 with 3 to the 5. And then the rule is, power of a power rule means we're going to multiply those exponents together. So 5 times 1/5, or 1/5 of 5 is just 1. So this will be 3 to the 1. All right, so 243 again, the 243 really is 3 to the 5. And again, 3 to the 5 to the 1/5. 1/5 of 5 is just 1, 3 to the 1 or 3. And so on with this. The fifth root of 3 to the, 243 is 3 to the 5. Spit it out, Logan, spit it out. So that's to the 1/5, and then that'll all be squared. So that's going to be 3 squared, because this part just equals 1, and that's going to equal 9. And then 243 is 3 to the 5, and that's to the exponent negative 2/5, and then I want to multiply those together. That's going to be negative 10 over 5. Negative 10 divided by 5 would be 3 to the negative 2, which will be 1 over 3 squared, which will be 1 over 9. All right, the last part here, if you want to give that a shot, you can. I'm just going to wheel through this. 0.25 is the same thing as 1/4. Now, Bob probably will want you to write these all in fraction form, and then this would be negative 2/4 when you use power of a power here to multiply those together. And then I want to add those fractions together. 1/4 plus negative 2/4 will be negative 1/4, and then that's going to be 1 over x to the 1/4, if we want to keep it with positive exponents only. The last one here, we have bases are the same, and we're multiplying. The rule is we're going to add those exponents together. So 3/4 add negative 1/4 would be 2/4, or 1/2. On the bottom, we're going to have a negative 3 times 2/9, so that's negative 6/9, which in lowest terms would be negative 2/3. And then I want to add those exponents together. So 2/4 is the same as 1/2. 1/2, sorry, not add. I want to take away negative 2/3. Going to get common denominators here. 1/2 is, common denominator will be a 6. So 1/2 is the same thing as 3/6. And then take away a negative will become a plus. And then 2/3 is the same thing as 4/6. So altogether that's 7/6. So that'll be a to the exponent 7 over 6. Okay, which you might see Bob rewrite that. I don't know whether he will or not. It could be written that way as well, using that power rule. I hope you understand.